So I'm going to be talking about Oumuamua, the first detected interstellar object. And what is it beyond that? Oh, by the way, I'm not an expert in these areas of astronomy. My background is in mechanical engineering. As an engineer at Raytheon mostly. So, I may be able to answer some of your questions, maybe not. And some of them maybe, there are questions out there that no one can answer. So in the presentation, I'll be, first talking about the observations of this object. The anomalies is really the heart of the presentation here, and different hypotheses as to what this object is. There have been some interesting related observed objects since that observation as well. We'll talk about the Sagan standard about evidence and what will happen in the future. I have 18 slides, by the way. So in 2017, the Oumuamua was detected. It was detected in Hawaii, hence this Hawaiian name, which roughly means scout, Oumuamua. It was also observed by SETI's Allen Telescope Array. That's a radio telescope array. And interestingly enough, they were directed to try to listen to this object, to get radio transmissions, and they were directed to do that by Avi Loeb of Harvard University, the chair of astronomy, who we'll be talking more about later on. And also the Spitzer Space Telescope observations. That's an infrared instrument. So what has been observed is the length of this object in the 100-meter range, tumbling with a period of about 8 hours. It's we don't know where it came from or how long it's been in transit, in interstellar transit.
Could you explain
yes?
what tumbling means? Is that like swiveling on a long axis, or is that going around in circles?
Well, actually, the observations are based on a single pixel. All right. All right. We'll see that later.
Okay, I'll wait.
Yeah. So it's hard to say what exactly the axis is, and what shape is derived from that. We'll see that data later on. So it's gone. It's long gone. It's exited with speed of more than 20 miles a second, which means we'll never be able to catch up with it. Objects in low Earth orbit at a speed of 5 miles per second, and escape velocity from the Earth is only 7 miles per second. And several important anomalies were observed, and we'll talk about those. Here's the path.
Just as a point of reference.
Yeah.
20 miles per second. How does that compare to any other objects that we may have seen in the solar system?
It's comparable. There have been, since this object was observed, there was another one observed, which is kind of surprising, and it had a comparable speed. It's I guess a reasonable speed for interstellar objects, as far as I know.
And judging from the video that you're showing now,
yeah,
the angle of incidence to our solar system is kind of unique. It's coming from out of nowhere and bouncing around us and going out.
Right. And its path took it inside the orbit of Mercury. It got close to the sun. It was only detected on the exit part of this trajectory. So the anomalies, there are more anomalies than this. Well, let me start with what I have on my list. It's shininess, okay, which is technically called albedo, the elongated shape, and non-gravitational acceleration. There have been other anomalies which have been referred to.
Excuse me, when you say acceleration, is the speed changing?
Yes.
Other than through gravitational force of our sun?
Right, yes. That's exactly right, yes. There's some kind of thrusting that occurred. It's not just a ballistic, say, trajectory or an orbital trajectory.
So this thing is producing some sort of power to, in fact, move it in a direction.
No,
according to
no.
physics as we know it.
It is not necessarily producing the thrust on board. It may be getting it from its close encounter with the sun, which I'll talk about more.
Then Ken, what
yes.
does non-gravitational acceleration mean? If it getting from the sun, that's gravitational acceleration, isn't it?
Right. So I mean, using Newton's laws, when you initially get the trajectory of this thing, you can predict where it should be going if it has no other external forces on it. So what I mean by non-gravitational acceleration, it had some kind of external force on it, which could have been solar pressure.
So this is prior to entering our solar system.
No, this was observed during its close encounter with the sun.
Well, I mean, isn't it that we're talking about the pressure of light as opposed to gravitational force?
Right.
So I'm saying the sun will exert a force that's not a gravitational force.
Right. Yes.
Okay. The old solar winds trick.
Yes.
Yeah. Apparently.
Well, no, solar wind is something else.
Those are particles.
Yeah.
Okay.
Yeah, and the acceleration was in the direction opposite the sun. And the other anomalies, they're kind of exotic, and they seem not as important and hard for me personally to deal with. So I just have the chief anomalies out here.
All right, a question.
Yes.
You said the non-gravitational acceleration was not coming from the sun, so that means that
No, wait, I didn't mean to say that. It apparently does look like it came from the sun.
So it could be that as it was going around the sun,
Yeah.
it had a pressure maybe coming from the sun.
Yes.
Okay.
Yes, that's exactly right. Yeah, that's what it looks like happening.
Could be boiling something off.
Right.
And
Yeah, we'll look in more detail at these anomalies.
So can you have an idea of essentially the magnitude of the acceleration that's coming up?
Yeah, I don't have numbers for it, but I'm sure the numbers are out there. So the shininess now, it's been observed that it's unusually shiny compared to let's say, asteroids and comets, at least 10 times higher than exhibited by solar system asteroids. And I have references for this and other things that I'll be talking about. And, a lot of these quotes with references, I mean, they are not always universally accepted. And you're going to see that a lot in this presentation. Here's the light curve, the intensity versus time. And, this is from optical instruments, a single pixel. All right. So, and from that, you can get the tumbling period, which is something like 8 hours. And, doing some more exotic math modeling, you can get some inference of what the shape of the thing is. And speaking of the shape here, like I said, the optical observations, they're based on a single pixel. The aspect ratio that comes out, 10:1, is much greater than that observed, from conventional comets and asteroids, which are at most 3:1. An analysis by this reference at the bottom comes to the conclusion that it's more like a disc shape, or also known as a cookie shape. Although the picture on the left is, what's typically been published in articles. These are all artist depictions, of course, right? The picture on the left is what's typically shown in many of the articles online about this object. And the one on the right is trying to get a artist depiction of what a cookie-like object would look like. Yes.
Ken, you talk about very high albedo, but that's an overall number. But there were
measurements made in different spectral bands. Is it high reflectivity in all of those bands? Do you know that?
I don't know the answer to that question. And here's the non-gravitational acceleration. The trajectory deviated from that you would expect just from the sun's gravity. And the push, as I said, was in the direction away from the sun. And we know that the sun exerts pressure on objects. And it's certainly, you can see that in comets' tails. You know, the direction of the tail is always facing away from the sun on a comet. But no cometary tail was observed on this object. The Spitzer space telescope, is a very sensitive instrument. It looked very deeply, couldn't detect any carbon-based molecules, even at a very low level. Now Spitzer can't detect certain other types of elements. We'll talk about nitrogen later. It can't detect nitrogen, and nitrogen has been asserted as a possible element to make up this object. However, it's also said that, if a lot of outgassing occurred, cometary type outgassing, that would have changed the rotation period. But the rotation period that was observed was constant throughout the observation time.
That's the 8 hours?
Yes, 8-hour rotation period, yes. Tumbling period. Now, some theories are, hydrogen iceberg was talked about early on, but that's been said to be at the very edge of feasibility as far as, hydrogen ice being created and surviving an interstellar passage. So that's been said to be at the very edge of feasibility. So I won't be talking any more about that. I'll be talking about two theories. One says it's a product of an alien technology. Okay, it's a kind of space probe, if you will. And the other theory says that it's a most likely, none of these is definitive, of course, most like a nitrogen iceberg, a piece of a Pluto-like planet that was ejected from another star far away from a long time ago from some sort of collision. And, from the quote on the bottom from an astronomer at Yale, none of these theories are a slam dunk. And I think you'll agree with that when you see more of this. So if we start with,
excuse me,
yes?
Ken.
Yeah.
I know that I could go through the math, but maybe you've already figured this out.
Yeah.
At 20 miles per second.
Yeah.
And the nearest other star system is whatever distance away it is. How long would it have taken to get into our solar system?
Well, we don't know where we came from. People have looked at tracking this thing back, and you have to track it back maybe millions of years, and then the positions of the stars are different from what they are now. So it hasn't been arrived at where this thing may have come from. But that's an open question.
20 miles per second is slow in terms of interstellar distances.
Sure, yeah.
So I intuitively, before I start doing the math, it seems as if it would take millions of years to reach here from any place that we can think of.
Right.
The thing to look at, I would think, would be if it's going at 20 miles per second, I think you said, that works out to so many miles per hour, so many miles per day, so many miles per year, so many years for light year. So how long would it take for an object going 20 miles per second to go 1 light year?
Well, the light is 186,000 miles a second.
Yeah.
So this is the ratio of 186,000 miles a second to 20.
Yeah.
So for whatever number of light years there is between here and someplace,
or less 9,000.
But you can't do this calculation until what is this? Is this an average 20? Is this what it's going as it's in its closest approach to the sun? It is accelerated by gravity the whole time it's coming in, and it's going very fast by the time it gets here. And you cannot tell how far it has come from just knowing how fast it's going when it gets close to the sun.
So Charlie, that's why my sense is that 20 miles per second is on the high side. It likely would be slower prior to getting to the Earth. So you could take that ratio of 9,000 to 1 and take an object that's some number of light years away, multiply it by 9,000, and it'll give you, I'll call it best case.
Okay, I mean, you can call it order of magnitude, back of the envelope. Yeah, sure. What you're going to find is it has had to come a long way. You know?
Right. Yes.
And the time is going to be, if not, probably millions of years.
Yes. Yes. That's what I said. Yes.
Yeah.
So that definitely puts it out past Worcester, right?
Oh, yeah.
Worcester on which planet?
Yeah.
Exactly.
UK. Okay. So the product of alien technology, we'll talk about that next. And that brings us to the book Extraterrestrial, published in February 2021. Instant New York Times bestseller. And it makes the case that this object is most likely of artificial extraterrestrial origin. The author, Avi Loeb, he's not just anybody, okay? Longest serving chair of Harvard's Department of Astronomy, author of 8 books and over 800 papers in astronomy, and a Lexington resident.
Get him for the group.
Okay, so in this book, which is, you know, no matter what you believe, I really recommend reading this book. It's really interesting and fun to read. So Professor Loeb comes up with the idea of light sails as a method of light sails have been built. Whoops. You know, we built light sails and launched them. They are a method of spacecraft propulsion using the same solar radiation pressure that we've been talking about. So the sail has to be, of course, a lightweight, a large area. And it would, you know, he makes the case in his book, it would possibly explain the shininess. You can actually see from the pictures on the bottom that it's necessarily shiny to be a light sail. Okay. Elongated shape necessarily as well. It has to have a non-spherical kind of shape. So it would need to be in the configuration of a thin sheet. And that would result in non-gravitational acceleration opposite the sun, okay? And it would result in a constant tumbling rate because it's not outgassing like a comet would be. Now, why would a space probe be tumbling, and why is there no radio transmission? It could be, there's a lot of could be when you talk about this object, and it could be leftover space junk from an old mission, no longer operational, no longer transmitting, but just set on some sort of trajectory and ended up near us.
Ken, on the subject of light sails, just because I'm ignorant,
yeah,
if it tumbles at some point in time, these are my words, the angle of incidence to the movement of the light would be minimized, and therefore you would be getting no effect. Is that correct? As it tumbles?
That's correct. Yes. Yeah.
I would assume maximum efficiency would be when it's perpendicular to the light, and minimum would be when it's parallel. Right.
Now the shape and even the size are guesswork, and the orientation certainly. You know, is it pointing towards the sun or away? That's unknown.
And I would think as it rotates, at some point, the light waves, the light sail would be a light anchor, because just the way it works, at some point it has to be dragging the object as opposed to pushing it.
I think again,
Yeah.
you're having to make some assumptions about this object.
Yeah.
It's very likely a fragment, not not the whole sail or something like that.
Understood, but
Yeah.
just based on what we have, Charlie, I have zero knowledge about this stuff. Don't get me wrong.
Yeah,
So-
since you have this light sail idea, and would there be a deceleration as the objects approach the sun? All this discussion has been about an acceleration after it has gone past the sun.
Well, the non-gravitational acceleration was observed during its closest approach to the sun. I don't know if that answers
what I
your
think he's
question.
saying is that,
Yeah.
sure, when it passes around the backside of the sun, it might get a push from the sun. Okay. But on its way to the sun, it's going to get a push from the sun to cause it to slow down.
But that's probably not comparable to the gravitational acceleration from the sun.
It never is. I mean, but
I wouldn't think so. But yeah.
yeah, and I think, yeah. Anyway.
Yeah. Okay.
I think it would greatly accelerate as it approached the sun and
Right.
close because it sweeps out an equal area per unit time, and as the distance is small, its speed would be very great. It's like being part of a gigantic ellipse or a hyperbola.
Right. Well, I didn't mention, maybe I should have mentioned this before. I mentioned its exit speed of 20 miles per second, but it's been observed to be traveling as fast as 50 miles per second near the sun.
Yep.
So, I've boiled down this whole book of Avi Loeb's into one or two slides. And again, I really recommend reading the book. Next, we go to the nitrogen iceberg hypothesis. Now, nitrogen iceberg asteroids, they've not been observed, okay? And what you may be wondering, what's a sublimation point of nitrogen? And there it is, about minus 350 degrees Fahrenheit. However, nitrogen glaciers have been directly observed on Pluto in the near horizons flyby. This picture on the right is meant to show some of the nitrogen glaciers. And, that would satisfy the shininess. It has been observed, the solid nitrogen ice to be very shiny. If you consider outgassing, then that would maybe give you the nitrogen outgassing away from the sun. Now, that was not observed by Spitzer because Spitzer can't really, it for some reason, it's an infrared sensor and it can't detect certain things like nitrogen. So maybe the absence of observation of outgassing proves that it's nitrogen. It's kind of a stretch for me. Now, as far as elongated shape, it's not really required to be part of this hypothesis, but it's kind of a non-player. But Avi Loeb points out, he feels that the if this thing was outgassing significantly enough to affect its trajectory, then that would have affected the tumbling rate. And some analysts even say that it would have torn apart an object like that into smaller pieces, which was not observed.
Ken?
Yes.
Maybe you're going to talk about this, but I'm wondering if if anybody has tried to make observations on what the composition of this object is. In other words, spectroscopic or some other ways of trying to figure out what the composition is. So we talk about nitrogen. Could they detect nitrogen, or is there a way to detect it? Maybe it's not possible.
Yeah, I haven't come up with any instruments that were capable of doing. You can do a spectrograph on a star, which is shining, but this is just an inert object. I'm not sure you can get a spectrographic reading from that. And I'm not an expert in this area either. So I don't know. It's something to look into, I suppose. Okay. Now, Avi Loeb points out, if this object was made of nitrogen ice, it should also contain carbon, and he has that assumption based on how carbon and nitrogen are produced together in the interior of stars. Now, Jackson and Desch, the people who came up with the nitrogen iceberg hypothesis, they speculate that maybe these elements are separated out somehow in the Pluto-like planet. It may be possible. Certainly it's again not a definitive thing to say. My question at this point would be, Spitzer didn't see any carbon at all, and it's a very sensitive instrument. How pure would this nitrogen need to be not detected by Spitzer? And that debate continues. Now, there was an International Space Science Institute team which looked at that. And to cut to the chase, here's their conclusion down here: purely natural origin. Now, it is an international team. I'm not sure that that whatever they come up with is a definitive answer. That's kind of a judgment call. And while I was, putting this together this morning, I was thinking, what would Carl Sagan think of this? And Carl Sagan's not around anymore, so I tried to find out what Neil deGrasse Tyson had to say about it. And there was a YouTube on it, and he's very non-committal about it. He's on the fence. Aliens are not my first thought. He does not endorse the let's say the alien hypothesis. So that brings us to the Sagan standard. Carl Sagan famously said extraordinary claims require extraordinary evidence. And I have my own comments following here. What is an extraordinary claim in this case? Carbon-free nitrogen icebergs? Is that an extraordinary claim? Or a light sail from an alien civilization? They're to me, probably both extraordinary. And what would extraordinary evidence look like? Well, if we had a high quality image from a flyby probe, but we don't have that. And we don't have any physical samples. So we have no extraordinary evidence for any hypothesis. And Loeb, in his book, he talks a lot. He has a lot of discussion about evidence and what we know and how we know it. And he points out extraordinary conservatism keeps us extraordinarily ignorant. And the idea of extraterrestrial intelligence out there and some evidence of it is extraordinarily important. So it may be important to at least keep this hypothesis in mind. And perhaps, what Sherlock Holmes said, when you don't have extraordinary evidence, what you have is theories, and the most probable theory must be the truth, arguable. And by the way, Avi Loeb points out as well, there's no evidence for dark matter, yet it remains a widely accepted theory, violating the Sagan standard. And the same can be said of probably other things like string theory.
Yeah, but dark matter is a name that is given to a series of phenomena, not necessarily that believed to be matter.
Okay.
I'd like to make a comment about the lack of carbon also.
Yes.
And that is one way of purifying a material. I mean, it's not really commercial, but is to freeze it. And what happens is that as the material forms a solid, it forces out elements that don't belong in its crystal structure. And so, to me, it's not, at least off the top of my head, out of the question that if there had been carbon around, it would have been forced out when nitrogen became solid.
That's interesting. In ISSI's paper, and which you can, I have a link to it. They just didn't address the whole topic of what you're talking about, as far as nitrogen being purified by freezing. It's interesting.
Hey, Ken, just to backtrack, something popped into my head.
Yeah.
After the discovery of this object,
Yeah.
was there much effort done to backtrack its entry to the solar system, looking at historical data that maybe it was overlooked before? You know, all of a sudden somebody going back on old pictures and slides and radio information, whatever they have, and say, oh yeah, there it is.
Well, this object is extremely dim. It was at best 20th magnitude star. Now, some of the stars in the night sky, they have negative magnitudes, so it's just extremely dim, and that's why they only got 1 pixel of information from it. You know, it's not really possible to, and they can't see it now with any instruments, any earthbound
Right.
instruments. Yeah.
I'm just wondering, you know, going backwards, they show an entry to the solar system, you
Right.
know, from an angle. So that means somebody at some point must have figured out where it was, or just, you know, 6 data points before it hit the sun, they said, okay, we'll draw a straight line through those.
Well, it's not a straight line. It's you do a fit to Newtonian mechanics. It's really commonplace. Yeah, I used to do stuff like that at Raytheon even.
One other thing that we haven't mentioned at all is that because of the distance it must have come, if you were to assume that some alien organization was able to, at the speed of light, receive transmissions from our galaxy and think that it's someplace to visit, they would have had to have gotten those maybe 1 million years ago, long before we had radio signals going out. So this is clear, even assuming that this is some sort of an alien object, it's pretty safe to say, I would think, that it wasn't pointed towards us, that
Right.
it could have been pointed someplace else. We just happened to be on the way.
Yes.
Yeah, maybe
You haven't
they
seen
wanted
Planet
to-
of the Apes, have you, John?
Well, maybe they wanted to understand why Venus is so hot.
Or it could be that there was a spaceship years and years ago, and this is an escape pod from it.
I'd like to know how old Loeb is, because I'm very suspicious of old guys when they start having theories like this.
Well, I don't have a picture of him, which I should have. He looks good. He looks like he's about 50 years old. I don't know.
Okay.
Yeah, I can't complain.
So a question about the
Yeah, it'd be brilliant. He turned 1 pixel into a book.
a question about the direction that it came.
Yeah.
So I've read that the solar system is perpendicular to the orientation of the Milky Way. So it's a flat disk. The solar system is perpendicular to it. And it looks like this thing was coming in from the side. So then it would be suggesting that it's basically oriented towards the galaxy axis. But was there any discussion about the direction in which it came and whether that would suggest that it was an intergalactic object potentially?
Attempts to come up with the origin of this thing have all been inconclusive.
Too bad.
Yeah.
So we can speculate anyway.
You know, it's probably been out there for millions of years. You know, it's been mentioned 20 miles per second. It's not that fast, and the stars are very far apart. So, yeah. So it's, you know, it's probably been traveling for millions of years. You know, and when you backtrack it 4 millions of years, like I said, all the stars are in different places now. So
sure.
Yeah.
Sure. Okay.
To answer Charlie's question, Avi Loeb was born on February 26, 1962.
He's a kid.
He's a kid. He's Israeli-American theoretical. This is from Wikipedia.
Yeah.
Israeli-American theoretical physicist who works on astrophysics and cosmology. He is the Frank B. Baird Professor of Science at Harvard University. He has been the longest-serving chair of the university's Department of Astronomy, 2011-2020, founding director of Harvard's Black Hole Initiative since 2016, and director of the Institute for the Theory and Computation since 2007 within the Harvard-Smithsonian Center for Astrophysics. Other than that, he's just your average guy.
He's no slouch.
No, he got good credentials.
Yeah. Okay.
Is that enough to satisfy you, Charlie?
Well, I'm now informed as to some more of his credits. Doesn't mean I believe him. And it doesn't mean I'm unsure that he would not write this book in order to make some money, or at least to get some fame.
I think, frankly, he's a Scientologist, but that's just me.
Yeah. Okay.
Yeah, sometimes people will write books or papers just to get research funding.
Sometimes
but that doesn't make them wrong.
Nope.
But if you look at his professional page, he's got all these projects going on. You know, he's also working on sending out light sails, for example. He has no dearth of funding or things to do. So, you know, you can see that really from his professional page.
Yeah, so he does have an interest in light sails.
Yeah.
Oh yeah.
Yeah.
He's trying to develop a market. Come on.
Well, the flip side of that, endowed chairs at Harvard usually pay the rent.
Yeah. Yeah. Well, he's able to live in Lexington.
Well, that's a whole different story, isn't it?
Yes. Okay, let's move on. So, since Oumuamua has been observed, an amateur astronomer of all things discovered a second interstellar object. And that just turned out to be a conventional comet. You can see the picture on the right from Hubble, actually. And as far as outgassing, it had a huge tail, 14 times larger than the Earth. So it was a very, very different kind of object from Oumuamua, sorry. And also since then, there's been an object that came close to the sun and was seen to react to the reflected sunlight. And that turned out to be an upper stage from the Lunar Lander Surveyor mission. So this was a large object, you know, an empty upper stage with very thin walls. So it had a large area and it was able to be influenced by the reflecting sunlight. So in future, there's a new observatory coming on in line in Chile next year. I say it may resolve the question. It's not really going to resolve the question of what this was. It's going to come up with a lot more observations of objects and detect them earlier before they come to our vicinity. You know, it's not clear that we're going to get a lot. How many of these we're going to see? And also, in closing, I want to mention a science fiction book, Rendezvous with Rama, talked about a fictional account of the first interstellar object, and that was rendezvoused by humans. As you can see that on the left. And it was a cylindrical object. Inside, we can see on the right, it was this whole city inside spinning and getting artificial gravity. And that's all I have for today.
And there was at least one sequel to that Arthur C. Clarke book.
Right.
But I mean, do you know the stuff of Jerry O'Neill out of Princeton? Because Jerry O'Neill aspired to actually have humans build one of these things. And, and I gave a talk, a couple of years ago about my experience with space colonies and designing one, not this big. But the O'Neill aspiration was to build one that looked a whole lot like the object in Rendezvous with Rama.
Looks like the Rama series is 4 books when you look on the.
Well, this was done by a team of Princeton physics majors under the guidance of Jerry O'Neill. They did a design, and checked out, strength of materials, would it work? How fast would you have to spin it to get simulated gravity? And they were designing it to hold, I think, 1 million people.
Ken, does Loeb speculate on the numbers of these extraterrestrial objects that might be out there and that we just can't observe them yet? Does he think there's a lot of them, or does he even say anything about that?
Well, I don't know if this is his number, but somebody came up with a number. If these objects were, in a solar system far away and were just expelled randomly in random directions, how many do we expect to need to be expelled before, we would see one far away on Earth? And the number is 10 to the 15th power. I'm not sure that you can get hard conclusions from that number, though. It's a big number.
Okay, Ken, thank you very much for all the effort you put into this.
Thank you. It's been fun.